is Efthymios, and today we will be talking about feature isolation, what it is, what inspired it, and how we can make cleaner code using this approach. So about me, in my day job, I am mostly a tech lead in integrations in Viable. Have over 13 years of experience, mostly designing and implementing microservices solutions and using Java, Node, but also did some front-end stuff with Angular and some other languages, React a bit, but not much. So that's my day job, but I do have an alter ego, and my alter ego is all about Flutter. So I've been involved in Flutter for over a year now, since before its 1.0 version. Some of you might know that era. I have created a couple of libraries under the Flutterings group in GitHub. I'm also organizing Flutter Athens. We are actually having our first meetup next Thursday. If you happen to be in Athens, you are welcome to join. I have assisted in the creation of FlutterX. It's a website that aggregates resources for about Flutter. And I have added a couple of commits in the Flutter main repo, but that was a while back when I was learning the framework. So how I approach software in my daily routine, in my work day, basically is based on 3 pillars: test-driven development, solid principles, and domain-driven design. And I try to look software development under this prism. Of course, I do write some dirty code from time to time when it's needed, but I try not to do that most of the times. So I mention this because this inspirement, domain-driven design, inspired me to make the feature isolation approach that I'm going to be presenting today. So who of you have heard of domain-driven design? Go ahead. Who of you have implemented, used, heard about it? Show of hands. All right. So I have some slides to explain very, very simple terms what domain-driven design is. We're only going to scratch the surface. Just enough so that you can understand my reasoning. So, domain-driven design, that's the definition. Cool, words. But what does it mean? Well, it actually means that it is a paradigm, a design paradigm that needs to depict real-world domain, real-world business, real-world problems into code with a constant feedback loop. Of course, every paradigm tries to do that. Domain-driven design has its own approach. If you want to know more about domain-driven design, those are the 2 fundamental books you have to read. Mostly this one, I would say. This is more hands-on approach. This is the book that started everything. This is the book that actually coined the term domain-driven design by Eric Evans. But this is the book that actually tells you how you can use it in your daily life. We are actually, in Viable, we are giving a copy of this book to every new hire, because this is how we do things, and they need to be informed. So, some concepts. What is domain-driven design, and what are its contents? The fundamental concept of domain-driven design is a ubiquitous language. What does that mean? It means that the business and the programmers need to have a common language so they can understand each other. If they're talking about one thing, this thing needs to have a name, and it has to have a name which is the same in business terms and in programming terms. This will reduce the communication, the miscommunication between the 2 layers, and it will increase the knowledge of the domain, both in the programmer and in the business. So out of this language, create some sort of dictionary, which forms a domain model, which is actually all the entities that and the concepts that are inside this domain. And of course, this is under a context of a domain. Most importantly, bounded context is which inside the paradigm of domain-driven design is not under concepts, but under strategic design. I won't mention anything about strategic design, just so that you know it's not a concept. Bounded context. This is actually what inspired feature isolation, and a bit about that. What is a bounded context? So, again, a definition. So, you have a description of a boundary around your domain model, which clearly sets the bounds of a certain sub-context. Let's say, for an example, you have in your application or in your domain, you have to have an authorization authentication mechanism, or authorization authentication domain or subdomain. This needs to be in a bounded context. You can call it access, you can call it, whatever the ubiquitous language you choose between you and your business is. But this forms a subtotal of your whole domain, which is whatever the business is doing. Actually, what it tries to do by using bounded context is to go from here to something like this. This is called the big ball of mud, and you can find this term inside those books. So this is a domain which is not correctly formed. Interdependencies, you can see arrows going all over the place. You don't understand what's going on over there. If you take this and draw some boundaries around certain areas, you have something like that, which makes more sense to you, makes more sense to the business. And actually, a bounded context can form a microservice, or a bounded context can form a set of microservices. So you see that there are boundaries around those contexts, and in the domain-driven design, there is communication between boundaries. But as I said, this is inspired by that. It doesn't try to copy that. So what's the development approach in Flutter? Well, there isn't any. Flutter is un-opinionated. So there is no formal approach of how you have to write the software, how you have to structure your code. Anything goes. So the developers are free to use whatever it makes sense to them. They're free to put their code inside a structure that makes sense to them. And Flutter has no opinion and enforce nothing on how this is done. Actually, this is what you get if you have an initial Flutter application. A single file. Everything is in there. If you want to split them up, have them in sub packages, you're free to do that. Flutter won't complain. If you want to have it all in one file, again, you're free to do that. Flutter will not complain. So when I started Flutter, I wanted to see what a good approach would be to structure your code in a way that could make sense. So I thought that maybe a good way to do that and a good place to start is the examples repositories from the Flutter team. So the Flutter team has created some examples, and these examples, of course, are posted in GitHub. So I tried to take a look at those repositories to see if a pattern emerges out of them. So maybe I can follow that pattern and have a peace of mind. What I saw, it's kind of like that. So this is only files. This is has only one subdirectory, and files again. This has a lot of subdirectories and files inside those subdirectories. Inside each repo, there is a consistency in naming, there is a consistency in structuring, but that's only repo specific. You cannot form a pattern across repositories. So you cannot have a way of knowing how can I structure my code in a way that makes sense and in a way that, it could be called best practices. So, as I said, across repositories, no structural consistency, no naming consistency, and most importantly, you cannot understand what this application does. You can open up a repository, check out the initial code, check out the files without opening anything. You know nothing about this application. For all you know, all the applications are doing the same thing. You don't know. You have to open up the application to see what it does. So let's take a look about code structure. How we structure code. Most of the time, what I've seen, it's fairly popular in Flutter, but in other languages as well. It's structuring by layer. So, okay, who uses layers in their application? And most of the time, well, I put those 4 representative. You can have more or less layers, but I think this, for me, it makes sense to have those 4. So you have the presentation layer, we have all the pages and all that you see in the screen. Services that takes care of the UI logic. The model, that's a description of the data you're getting, and of course the API/repository, which has all the communication with either a data store or a REST API. So most of the time what we do is this. We take the layers and we try to apply them in our code structure one by one. So we put all our pages together. We put all our models together, repository services. Everything is grouped by layer and by type sometimes. And I guess that's okay if you have like a small project or if you're the only one who's working on that. But again, where are the features? If I open up this repository, will I know what this application is doing? Will I know what this application is about? For all I care, this application does the exact same thing that another application does that has the same structuring. Again, only looking at code. So here are the features. They're hidden away. Either best case scenario is that inside the layer folder you might have feature folders or feature files. So it's pretty distinct of what you are doing, but it's inside the layer. So this feature of one here is span across 4 layers. And it's most of the time, that's what happened to all of the features, or most of the features. Here you go, there are your features, and you have carefully tucked them away in a way that makes sense to you. And I'm not here to argue, I'm just here to suggest. So let's shift the paradigm, and instead of organizing our code by our layers, let's organize it by feature. This is not new. This is called feature packaging. It's here from, I've been using it for at least 8 years now, and it is something that is derived from domain-driven design. What does this say? It says, instead of structuring our code according to the layers, let's put all the feature, all the components on all layers of a single feature inside a package that is called a feature. So let's say that we have 4 features. Let's package them accordingly. And again, you just translate that into a structured code, and then you have features. What's the difference now? If you open up an application and you see like invoicing, access, payments, you might understand what this application is doing without opening any other file. So instead of tucking away the features, we emerge them and have them as first-class citizens here. But wait a minute. Does this ring a bell? Does this remind you of something that you have seen in the previous slides? Maybe it does. See how from a big ball of mud we emerged with bounded context? I'm not suggesting that layered packaging is a big ball of mud. It might as well be very well structured inside the package. But I have seen code that I cannot unsee, and I would say that big ball of mud is the case. Well, not all of the time, but from my experience, most of the time. So, okay, here comes feature isolation. How can we have features that are isolated and that we can promote clean code inside our repository? First of all, structure by feature. If you structure by feature, then whoever opens up the application, your repository, will have a hint of what this application does right from the bat without having to look at any other code. But can we stop developers from leaking features between them? Can we stop developers from having this feature using a piece of code from this feature? Might as well we have a developer that has a need that knows that, you know, feature 2 does that. Let me use that instead of doing something else. So they just import that and they use it over there. So packages alone inside the code does not isolate them, does not isolate the features. They are still susceptible. And this is too hard to catch in code reviews because you have to check every import inside your application. And we're humans, and a lot of the times we don't catch everything. So, no, we cannot isolate them. So, how can we isolate features? Let's see how we can approach an isolation in features. First of all, being dry and all, we want to have common code somewhere that we can reuse. So we need to expose shared code in some manner. And again, we have to control what the feature exposes to the rest of the environment. We have to control it in a uniform way, so all of the features will expose the same things. This can be done with a shared interface. I think it's a good approach to think of it as an interface. A feature should not communicate with any other feature, because then we don't have isolation. We have chatting features. So we don't want to communicate directly with another feature. And what you have is the root context. So the root context, because it needs to build an application, it needs to know all of the features so it can compose it and create the application. So we need to have some root context, some root feature. Basically what I just said can be summed up into this diagram. We have the root that knows all of the features past the shared one. We have a shared one, and features know only the shared one, and the features expose their components through a common interface to root. So, shared packages. Solved. Just put a shared package there, put your common code there, and, you know, features can just use that and be dry. All features should compose. So how we control the export of components from our features? Basically, we have to think about what we need to export in features. First of all, we need to export routes. We need to know where our navigation is. If we have multiple pages per feature, we need to know how we can get there. So a feature context should export its routes. It could also export not only routes, it could. If you're using a certain router provider like Fluoro, you can export like a Fluoro-specific thing here. But every feature needs to do that, not only one. So, yes, you can export routes. Let's say that you have a drawer and you have menu items there. And because the features themselves know their navigation, their routes, they are the ones that can provide a menu item that can link to a route. So let's export that as well from each feature. Now, the hard part is to enforce that the features should not communicate with each other. And if you take a look at even at the main Flutter repository, you will see a structure of code that uses a packages folder inside the root. So, packages. Now that we have all of our components of single features inside a package, we can promote this package to be a library. So feature 1 is a library, feature 2, 3, 4, and the shared is a library. So if we do something like that, we can enforce that feature 1 has no dependency in feature 2 through its pub spec. We can even automate that through our CI by just parsing the pub spec camel against a wide list of dependencies that the features might have. So the root pub spec looks something like that. It has dependencies to all of the features that are now libraries and not packages, so that it can compose the application. It needs to know every single one of the features. And this is just a part of a feature pub spec YAML. It needs to depend on the shared library, because in the shared library we have all the common code. So the root context needs to be aware of all of the features so it can compose the application. How we can do that? Just show that. We have the feature libraries as dependencies to the root context. And we create a new, let's say, interface that has a registry of features, well, actually not a registry, a list of features that get registered in its constructor. And then we expose the exact same things that every feature does. So now we combine all the routes of all the features because we have the features and we have the routes. We combine them all into a single map, and we put that map into the material app, and now we have navigation. Again, for menu items, we combine all the menu items that are exported from our features, and we create the drawer with the menu items there. But what about state? Big question in Flutter. What about state? It depends on the library of choice, or as I often call it, your poison of choice. It depends on the library. So it depends not only on the library, but also on the needs of the application. If your application needs to have a global state, it needs to keep state globally, and even if a route gets popped out of the navigation stack, it will keep its state. Then what you have to do is to export your states, and you have to export your state altering processes. I haven't put code here because it will differ depending on the library that you have chosen, and because this is a talk of its own. So export your state and your state altering content. If you, on the other hand, don't have the need of popping from the stack, then I guess you can just isolate the state as well inside your feature, and that's perfectly fine. But if you don't want to have global state, you don't need to have global state, then you don't expose anything. Dependency versions. How can I be sure that all of my dependencies are uniform across all of my libraries? Because now I don't have packages inside one library in one application and control all of it from one YAML. I have 5 of them, and I need to be sure that all 5 of them have the same version of the third-party dependencies. Well, Dart's website has the answer. The dependencies in Flutter, in Dart actually, so transitive dependencies are treated as immediate dependencies. What that means is that if A has a dependency to B, and B also has a dependency to C, then A also has C as an immediate dependency. So you can get that out of the right from the bat. So in order to be sure that everybody has the same versions of their dependencies, you put them into your shared library. You put them in your shared library, your pub-spec in shared library, and then because shared library is a dependency to all of your other libraries plus your application, then all of your other libraries plus your application have the same version of the same dependencies. So how can I synchronize dependency updates? Let's say that I update provider X to provider Y. And then I need to run the Flutter packages pubget or Flutter pubget. Yes, both of them work now. To all of my libraries. That's like 5 times doing that. Well, it's not a big hassle because we are programmers and we can just come up with a script that does that for you, put it in the root, run that, and you have updated all of your dependencies. Benefits. So what are the benefits? So we keep talking about how feature isolation is cool and how feature isolation, well, I say it's cool. I haven't heard from anyone else. But how feature isolation will solve a lot of our problems. What are its real benefits? Well, its real benefits come here. You have a low learning curve. You don't need to know anything more than put everything that is that is inside a certain feature, put it in that feature. You only touch, let's say that you're working on one feature or feature 1, you only touch feature 1 library. And if you touch only feature 1 library, then you know that you're not going to get any conflict. It's recognizable. If you open up a repository of an application that's using feature isolation or feature packaging or feature libraries, you can immediately, without opening up a single file, a code file, have a taste of what this application does. If you see invoices, if you see payments, if you see customers, if you see sales, maybe there is an application that's doing something in financial sector. If you see, on the other hand, I don't know, some sort of other features in another domain, you can expect to find more of them concerning the same domain. It's maintainable, as I said. It reduces conflict. It does not eliminate conflict. You may still have conflict if you are working on shared code in your shared library, but you will not have conflict if multiple people or multiple teams work on different features. They're just touching one piece of code, and that's it. And imagine that you are a team and you get a new member of that team. Immediately, this member can recognize what this application does and can, be kickstarted on how to do things and what this domain is about. Scaling. You can scale that. You can scale it either as a monorepo. You just leave it as it is in one repo, use it as a monorepo, and have everyone, have complete control of it. Or if a feature gets a life of its own, you can just take shared, of course, with you, put it in another repository, and have the application depend not on the path, but on the repository. So this can scale. This will help big teams. This will help big projects. And that's what I wanted to present. Not a lot of code, some abstract context, but I really like to think hard about how I'm approaching software development. Some of people think that thinking hard is idle time or time wasted. I don't agree to that. So that's it. Do you have any questions for me?